Hello, everyone. Before I begin this presentation, I want to get a bit to know like the audience a bit more. Can you raise your hand, those of you who've already deployed a blockchain node by themselves? Yeah, yeah. So quite a bit of you. So let me first introduce myself. I'm Pierre Besson. I worked as a DevOps engineer at Parity Technologies. In my work, day-to-day work, I mostly like operate blockchain nodes on, and mostly also on the testnets. So in this presentation, I want to give you feedback about DevOps at Parity and like our testnets. But I would say I'm not like, it's not just my work, it's also the work of the entire DevOps team at Parity. Right now, we are 15 people, including the bot. And so as part of my work at Parity, I helped initiate two projects that I think interesting, and that's also my goal to present today, which are the NodeMchart and Testnet Manager. So the idea of this presentation, so a bit of a warning, it will be about 45 minutes. In the first part, I will present kind of the history and our journey operating these blockchain testnets at Parity. Then the second part, I want to present this open source stack that lets you deploy and manage testnets on Kubernetes. And the last part would just be kind of a conclusion and some personal feedback from my experience. So if you're OK, let's jump in the first part. So just maybe as a bit of an introduction, what is a testnet and why we want to have this kind of blockchain networks. So this idea of a testnet is to create a simulation of a real like a blockchain network, which doesn't hold actual value. So it's just, let's say the tokens are free. And you want to have this because you want to validate your code, and you want to be able to debug. So from like just the user point of view, it's already helpful to have testnets because you can basically try and send transactions for free. You can try out interoperability. You can try out different apps that like connects to the blockchain, but don't necessarily, even if you don't even have tokens. But even more importantly, for the chain developers, it gives you tons of like interesting properties. So if you're like, in general, you can test node client upgrades. You can validate your runtime. So when you develop a new version of the runtime, you upgrade the testnet first. I say you can comprehensively observe the networks. It means that when you run a testnet, usually you will actually own all the nodes, so you have access to all the logs of all the nodes. And more specifically, in the context of Parachains, you will be able to dry run the onboarding of your chain on the relay chain, and also have access to useful logs that can help you debug your relay chain, but are actually on debug your parachain, but that are actually on the relay chain. Then to zoom out a bit, so DevOps for like operating blockchain nodes. So blockchain nodes are not like regular. It's not just like your regular applications. It's not. It's definitely like stateful, and it's a database. So you're never going to be able to manage your blockchain nodes like you manage like a stateful application that you can horizontally scale. It's really critical to think that those are like database first. And moreover, you have all this distributed system thing where all your nodes are actually connected to each other with this P2P stack. You also have a lot of like requirements to keep your nodes secure, especially for like production for like the main net. You have also these key management, so you have a lot of keys to manage, especially as the blockchains become more and more complex, and monitoring, of course. Then, in the context of testnets, specifically, you will want to scale up and down the number of nodes or validators, and upgrade them super often. So as you upgrade them super often, it will obviously break more often. And what's important to know in blockchain networks is if you ever break consensus, you basically have no choice but to like outfork or reset the chain. So initially at Parity, our approach is to use configuration management like Ansible for managing our nodes. And for this, we actually have recently, like this year, open sourced this, this Ansible collection. So you will be able, you can maybe check it out and see a bit how we do it. So using Ansible, it has some advantages, like you will use Ansible to manage all your nodes, and you have basically the same script. So whether it is a testnet or a mainnet, you just use the same script. It's also more secure, because you limit who can connect to your nodes. Let's say that our practice is to connect via SSH and use like something like a YubiKey. But it has some disadvantages that we like the problems basically that we hit. It can be slow, especially if you want to scale to more and more nodes. And we can't really provide developer self-service, because that would mean giving like SSH access to all the nodes to the developers, which you want to prevent. And generally, it's not very well automated. Okay. So the challenges we had with our testnets at Parity is the need to scale. So the number of developers that are actually in the organization just grew a lot. They also ask us to manage more and more testnets. So initially, we just have like one testnet, West End. Then there is this Rococo. And then there are also all the Parachains that are connected to those testnets. We also have this kind of challenge to be able to scale the network to 1,000 validators and scale up and then down. And for this, the solution with Ansible was not enough. And we also wanted to lower the time like, let's say a developer has a new code, he wants to actually try it out in one of the nodes. Then they will ask us, and then we would have to deploy manually. And at the end of the day, this would prove like super painful also for like our DevOps team. And so the solution is using Kubernetes. And we also took this occasion to kind of more open source what we do, like the kind of configurations we use. And this is also the goal of this project, the NodeMchart collection. And also, the second thing we had to do is to script the node key management, and this would be like the second tool, the Testnet Manager. So I will put back the links on the last slide if you've not noted it down yet. Okay, so now we reach maybe the more interesting part, is like what is this kind of tested stack that we actually developed. But more now, just one slide to justify the use of Kubernetes. So Kubernetes, it's the most mature orchestration platform right now available to us. But more importantly, all our DevOps people were already very familiar with it. And so I assume even in your organization, your engineers a lot that will be very familiar or just want to learn it. In the context of like this blockchain, stateful databases, Kubernetes has a lot of advanced networking and stateful workload support, and also persistent volume management that proved like very helpful. And it's also a different approach to managing your infrastructure, where you have this declarative first approach. And this lets us automate some of the operations much more easily than before, like restarts, rolling upgrades. Also have some kind of self-healing, so it would use the health check and be able to roll back on startup failure. So just to give you a bit more of a concrete example, so in the past, where we would just push a new version of the client, and this version was somehow broken, it would just so the node would just fail on like startup. And when we were using Ansible, we would just roll these new versions to almost all the nodes, and it would try to just like upgrade and just restart the node, and then this would actually just break. And then maybe it will be able to roll back, but it will roll back individually on each of the servers, whereas in Kubernetes, it has this kind of global view of all your cluster. And so it's actually the way it works is it just tries to upgrade one node. And if this node actually fails to start, it just rollbacks the entire process. And this is actually automated for you. With Kubernetes, we are able to specify our configs, reuse like blocks of configs between, or like the way we set up the resources between different networks. It's useful for us because we have a lot of testnets, like Parachains and stuff like that. We are also using Helm to abstract away the complexity of the setups, even if you don't know all those kinds of like Kubernetes specific resources. The Helm charts just abstract away most of this. I will show you some example just after that. And also, nice thing, it integrated well with our monitoring stack. So our monitoring stack at Parity consists in Prometheus for the metrics, Loki for our logs. And for us, we were already running our monitoring stack in Kubernetes, and there are actually some very good tools that just let you automatically connect or like scrape the monitoring endpoints of your nodes if they are running in Kubernetes. So this is our NodeMchart project. As you can see, we offer a few in like NodeMcharts. The one I will talk about today is the node. That lets you like deploy any generic substrate node, but also a Polkadot or like even collator for Parachains. This collection has a few other like charts for like different things, but I won't dig into it today. So the NodeMchart, so it's a project we've been working for a few months, and we actually rewrote it a few times already to kind of achieve something that we were satisfied with. The idea from the beginning is to be able to support any kind of substrate node, so I think it will adapt to any network that you run if it's based on substrate. It's also useful for validators and collators, and I will also just after that I will show some specific examples of how you can just use it to configure like a validator and a collator. The way we manage the blockchain nodes in Kubernetes is obviously it's based on the stateful sets. So the stateful set, if you don't know it, is simply a way to manage a set of pods. But with the similar config, and also the sets will be ordered. This means, like, for example, you have a set of validators. The first will be like validator 0, then validator 1, validator 2, and they all share the same config, but they have this unique index. So this I already told you about. The NodeMchart also will let you correctly expose the P2P ports. Because those blockchains need to actually be accessible on the internet for like their P2P networking. So we provide a way to achieve that with Kubernetes using different kinds of Kubernetes services like node port or load balancer. We also provide the facility to inject keys directly into your node. So this can be using like a Kubernetes secret or HashiCorp Vault, or even maybe we could extend to some other ways. We also let you expose the RPC endpoint through an ingress. And so it could be relatively easily to manage like an RPC, even like load balance RPC, many nodes behind actually a load balancer that expose the RPC. And also something that we are using a lot, which is to retrieve the chain database from like a snapshot and just download it and unpack it on the disk. So when your node starts, it already has all the data, and it doesn't have to sync from like a block 0. So this is what it looks like. As you can see, you just have this very simple YAML file, and you use Helm to deploy your node to Kubernetes. So on this part, you have just the Docker image and the tag. Here you will specify the chain you want to connect to, and then this kind of config translates to a set of flags, like command line flags that will just be set on your node. And also it translates to a set of Kubernetes resources that will manage the container on this platform. Here I specified I want an authority node, so it just means that it will be a validator. Here I say I want 10 replicas, so this will just actually create for me validator 0 through 9. This part, it lets me specify a bit what kind of chain database I want to use. Here I'm choosing Parity DB and pruning 1000. So pruning, if you don't know, it's a way to specify how many blocks you want to keep in the chain database since the last, like before the last finalized block. So last finalized block minus 1000, in my case, 1000 blocks in history. And all the other blocks are just discarded. And here I'm also specifying a volume size of like 100 gigabytes and some custom flags. Here I just set the beefy flag on my node. I just also set some. So we have a bunch of small, useful like configurations like log levels, but most importantly, you will want to adjust that. Sorry, I don't think I can take too many questions, but please ask if you. Yes, so it has to be specified like this, with like the resources, request, and limits. And so basically what you set on request is what is allocated for your node. Like it cannot be allocated to any other pod or workload. So you have to set at least a minimum, and the limits, then it could grow up to the limit. So let's say like here, this 3,800, like this means just 3.8 CPUs, and this means 7.5 CPUs. And the node will have 3.8 CPUs like reserved, but it's able to grow the CPU usage up to 7. And but this is just the way Kubernetes works. If by chance you just use more CPU than that, Kubernetes will throttle you. They will throttle the CPU. So then you look at your metrics, and you realize that you got some throttling, so maybe you just adjust this to be a bit more. Yes, so this is something I never experimented about, but would be very interesting to have this more of like this elasticity. So it's called the vertical pod autoscaler. So this is another example that's deploying a parachain collator. So as you can see, it's basically a bit the same as before because it's a substrate node. So it can reuse like the same kind of configuration. However, you have some things that are a bit specific. So if you know a bit about collators are actually nodes that syncs two blockchains, the parachain and the relay chain, and that's why they actually have two separate databases for like those two blockchains. And what we are configuring here is that the first database that we want to sync is the relay chain. So let's say you're a parachain of Polkadot, you sync with the Polkadot chain. Or here it's more like Rococo, but so here you see that I sync with Rococo. For example, I will set up my chain spec like that, and the chain database for Rococo. Here you can see that I actually am pulling the data from like this GCS bucket, so it's basically very similar to an S3 bucket. And this lets me like start my node much more quickly. I don't have to sync the history like through the P2P networking. Then this is the command. This is custom chain spec URL. So let's imagine that you have a testnet. Usually you will actually define a custom chain spec so that your network is unique or has some like properties. And here you see that we actually have two different custom chain specs. One for the node, so the parachain. So it will be the parachain chain spec, and this one actually is the relay chain spec. And same, you have like these two chain data configs. So I don't know if it's really easy to see, but here you actually are under a node for like chain data. This chain data is under the node, and this one is actually under node collator relay chain. So it's like one level more of indentation. This is to demonstrate a bit this key injection feature. So when you want to bootstrap like a testnet, it's interesting to inject some keys. And here, for example, I just put like this key that is of type like Aura and using like this seed. And then we also have this trick of using derivation. And so this trick will actually just create a derived key that will be unique for each of the nodes of the set. Like here I have a set of 4, and this will actually derive like this. So the first one is test, then / node 0, and then node 1, node 2. And this lets us have something unique and bootstrap like a testnet very easily. Here I have the parts where I configure the node services. And so here I will specify a P2P service of type a load balancer. And so this lets me actually define my node as a boot node very easily. Okay. So I hope this configuration example just helps you a bit understand what this helm chart can do. But actually, our experience in managing testnet is that just deploying the node is not enough. You actually have some operations that you will need to do on the node. And these operations are like key management or something. So here I have a simple example for you, how to add an extra validator or collator to an existing network. So you would just go on the node and generate session keys. And this is usually a manual operation. And then on chain, you submit this set keys transaction with the public key of the keys that you just generated. And then, as you are like the testnet operator, you will submit also a pseudo transaction that just marks this new node as like part of the active set of validator or like collators. So this we used to be doing just by hand, and then we started scripting these operations a bit more. And then we also realized that not only we need to script these like key operations or like management operations, but it's also really hard to keep track of which validator is currently active or inactive. And if you have a parachain, then you are especially for us, we are onboarding many parachains to test the system. So we wanted to facilitate onboarding and offboarding of parachains. And so this is why we have created the Testnet Manager. So the Testnet Manager is a small application that we developed in Python, and where we have an API. So like that's just like a Python API. And then it connects to 2 sources of data. First, the relay chain node, so like via RPC. So this way we can get the chain state. So the chain state, for example, for us is who are the validators, what are their addresses right now. And then we get the data from the Kubernetes API, where we get just the list, basically, of pods, of nodes that are running in our cluster. And so basically here I will have a very simple cluster where I have 2 VM pools, one for the relay chain, one for the parachain. And once I have my status from both of those sources of data, I just kind of map them together. And then I'm able to also connect directly on each node's RPC port to do these operations like generate keys. And then I'm able also to do the pseudo transactions. So basically, I will just give it the pseudo key, give the pseudo key to the Testnet Manager API, Testnet Manager app, and it will be able to perform the operation in a more automated way. We also have this simple UI that I will also demonstrate, and that will probably make it a bit more clear what the tool does. So this is a view of the API. So as you can see, the tool lets me list the node, list the validators, list the parachains, list the collators for each parachain. And then I'm able also to do some actions, basically, like kind of like the operator. So like register this validator, register this collator, rotate a session key, onboard a parachain by just giving a para ID, and then register or deregister the collators. So just to give you a bit of an idea, so this doc is interactive. And here, for example, I decide to register two validators. And then I give it like these 2 new addresses. of some nodes that I have already set up and for which that I want to add to the current active validator set. So let's say those nodes were not running in Kubernetes. But if my node was actually running in Kubernetes, I would just have to put the stateful set here, just the name, and then the tool is able to just find the node running in the cluster and then just set it up for me. So this is what the UI looks like. So as you can see, it's listing all my this is actually the view of Rococo right now. So we see we have 100 active Kubernetes validators. One, for some reason, is inactive. Maybe it has some issues. And here you see the name of the pod that is running in the cluster, the address. So to get the address, basically we use a kind of a formula where basically all our validators have the same root address, and then we use a derivation. And then it's able to map the current. Then by mapping with the on-chain state, we can know if it's actually a validator or not. So here I can display if it's active or not. I can also review like the versions. But mostly, what's important to see is like this address. Those kind of links that would just have the address in the links. So for example, I could just jump to Subscan or jump to our Grafana to get the logs of like this node. Here I just want to show you these keys. So I'm also able to list the different keys, like those are the public keys, of course, of like the different protocols. And it's also very useful because sometimes when you look at your logs, in like your log aggregation, you will find this kind of keys, which sounds a bit cryptic. It's not really easy to know which node on your cluster it actually corresponds to. And so by using this list and also using this search box, you're able to very quickly match this public address of this like protocol with this specific node. You also have like this drop-down where you can select the stateful sets. So here you see I have A, B, C, D, E, F, blah, blah, blah. By clicking this, by clicking like this A node, I will just jump to view only the nodes of the stateful sets, and then I will get these buttons that can perform some actions. So if I click like register, it just register all the validators in this set, or they register, and then it they register all the validators in the set. And the good thing about it is that we worked also to parallelize the operations, so we can manage like these fleets of nodes quite conveniently. If I click on just one node, here I have a link, and then I will also have a single node view. And there I will find all the information of my node that I can retrieve from the RPC endpoint. So there I have it as just at a glance, like my validator account. This is the other feature that we have is to manage parachains. So this is just the list of parachains that we get from the on-chain state. Here you have like one parachain, which is RockMine. So this is the instance of StateMine that is running on Rococo. You can see that it's actually detected that it was running in the cluster. What else? And here you can see like 3 other parachains, and those are actually from the community. So we don't own the node, and we don't know a lot about them. But we still can list them. And as we have the sudo account, we are able actually to just offboard them if we want. If I click here, like on this like 1000, then I get the collator view. And so here my Testnet Manager has detected the collators that are running in my Kubernetes cluster for the parachains, for parachain 1000. And here you can see that those are actually not running in my cluster right now. They are external, so basically they're kind of unknown. We can see that their collator status, so it's a bit similar to like the validator status, but it's like for if this collator is producing blocks. And here you have the external collators. And here you have basically kind of the same view where you have just all the properties of your node. And you find also the collator account, which is actually obtained in the same way as the validator account. So, now we reach a bit the conclusion about like what we learned doing all this testnet management at Parity. So this will be a bit more like a personal feedback. So what I learned is that when you have like larger and larger testnet, operating the nodes in this like manual, individual fashion is not a good approach. Then Kubernetes actually worked for us to manage stateful workloads. I mean, you probably, if you work like with Kubernetes, you probably heard that it's actually not well suited for stateful workloads, and that I think that's also good reasons to say that. But by putting enough like investment into learning those a bit more advanced like stateful sets and more advanced like Kubernetes resources, like persistent volumes and things like that, you are able to make it work. I mean, we were able to make it work. We were able to increase the speed we were doing the deployments. So today we are able to deploy dozens of nodes in a few minutes, then to just remove them very similarly. We are able to experiment more often, so this led us to create an internal testnet for like our experimentations. But I mean, also using Kubernetes has some drawbacks. Like the first one is it introduces a lot of complexity. It's definitely more complex to manage all these like resources and to understand when Kubernetes is not doing what you want. Then obviously it reduces security a lot. I mean, you see that we are using, for example, the sudo account in our application. But we still believe it's a good trade-off for the flexibility it brings us to experiment and simplify our work. And of course, we are only talking about the testnets here. And one thing that I also don't like about it is that it creates a differentiation between the testnet and the mainnet. So now you're not using the same tools to deploy them anymore. So it can be a bit of a risk. So my conclusion is try to use the right tool for the job, same as always. But more importantly, you have to think. We have to think about blockchain infrastructure and like these operations in like a different way, like using different approach depending on what you're trying to achieve right now. Like if you are trying to do a local deployment, don't use Kubernetes. It's way too complicated. We have other tools like ZombieNet. So I think the ZombieNet presentation was like at the same time as this one, but definitely check out ZombieNet and ask around if you want some more info about it. I think it's a super interesting tool. Then for each of these environments, you will have to find the trade-offs. And for me, the trade-offs are along those lines. So do you want a temporary network? Do you want a persistent network? What size of the network do you want? So just a couple nodes, or do you actually want to scale it more? And in this case, it makes sense to invest into these Kubernetes tools and this stack. This again, what do you prefer to have? Security, maximum security, or like maximum flexibility? Do you want to provide your developers with self-service? It can be super empowering for the developers to have access to deploy their own code into the testnets. And then you have also some hard problems that are not the subject of this presentation, but monitoring is a big one. Hopefully, we will be able to do another session on monitoring like in the future. Then this idea of decentralization versus control. So it's not really like the same thing that like on production networks. It's more about you are operating the testnet, and as an operator, you want both at the same time. You would want to have decentralization. Like you would really like if you could have some people from the community that run some testnet nodes for you. It reduces your cost and it shares a bit the burden. But at the same time, if you start to do that, you lose some control about how frequently you can upgrade, and like obtaining the logs of like every time there is an error, So this is like a question that we are really thinking about deeply right now, especially for Rococo. And you also want to minimize downtime when deploying these new codes. I mean, if you deploy experimental code, it very often will break. And as as I said before, if you break the consensus, you break the chain. So what I want to summarize it a bit in this last table is that for me there are 3 ways to manage blockchain networks. Just the first one would be just local or in your CI, and this would just be a temporary network that you spin up, and you don't really you just want to test one thing, and then you can just destroy it. Or you have the testnet, which was the subject of this presentation. And finally, you will have the mainnet. So in terms of automation level, what I would say is that these local CI stuff, you should strive for full automation. But for staging, you actually don't want full automation. You would want something like this semi-automated, because you will want to be able to get to persist the network across like this upgrade. You will want to be able to scale up and down. And this cannot be achieved like fully automatically because of those the properties of like those tools. And for production, you probably don't want actually to automate anything because you want to keep the most control and the highest like security. And so I think like it maps a bit into this kind of operational model. I don't know if you've heard about this, like this cattle versus pet, but what this Kubernetes and like those tools allows us to do is to manage our infrastructure like cattle that we are like herding around. Whereas for these production mainnet nodes, you will more likely want this like pet approach, where you are very careful about every action that you do and try to minimize the risks. Then on the infrastructure side, what a testnet approach will be able to do is to fine-tune the specs. Something that we also like discussed briefly, like how much resources do you need. The testnets are really the place where will be able to adjust this, like this resource usage, and you will be able to experiment. Whereas on production, you just need to strictly follow the requirements, like especially like if you're a validator. You don't want to experiment too much by just lowering like the CPU or memory, and then just get slashed. Finally, those are the tools that I would recommend. So ZombieNet for local and CI, Kubernetes plus Testnet Manager for staging, and finally Ansible or something similar for production. And then I guess it's more about what you want, how big the networks can be. But we've been able to scale our testnet to hundreds of nodes, thanks to like using cloud providers and Kubernetes. So we've now arrived at the end of this presentation. There is a link for a testnet example. It doesn't work right now, so like it's empty, but I promise I will add the example by tomorrow and the sample code so you can actually check it out. And so tomorrow there will be a workshop at the Parachains Summit. I know some of you might join, and this would be like the opportunity to like directly interact with each other, and so we can actually demo you in person. Thank you very much.
Hello, thank you. We do have time for, sorry about that. Oh, Doug. Is it okay? Okay. We do have time for 2 questions, so I see there's no? Oh, okay. Perfect.
So it's more of a philosophical question.
Okay.
I don't really have a lot of experience building infrastructure on blockchains.
Mm-hmm.
So as far as I understand, these nodes are hosted by various different entities or actors, which actually ensures or enforces decentralization. But what if all these entities, at their turn, they are hosting their infrastructure on AWS and GCP, and then they basically plug off isn't the whole blockchain gonna like just disappear?
Yeah, that's actually a good question. But I mean, my presentation today is really about the testnet, like how we can test things. But for this, like this, the problem of like centralization, and I think you will have, you already have some statistics on where the validators are running. There is like a website called Polkadot. I can find a guy here that actually measures that. But it's not, so yeah, it's not something I worked on.
No, it's just more like a philosophical question. If you have any thoughts on that.
But I think that also what we try to do with these tools, I don't think like this NodeMchart. I think this NodeMchart might get like more production ready, but I don't think I would recommend it for the validators. Like my last slide, I think is pretty clear. Maybe in the future, or like if you're really confident about Kubernetes. But for like regular nodes that you would interact with, like RPC or boot nodes, I think the NodeMchart could help you, and could help, and also because there is nothing very specific to any cloud provider in our tools. In these tools that I presented. So I think the future is pretty bright because we have tons of open source projects, like in this container Kubernetes space. So I think it's really good for like decentralization and. To let anyone operate more easily like these kind of blockchain nodes. And
do we perhaps have one more questions for Pierre?
Just a quick one. I know, so what are you doing around Secret Manager? Are you using like a Vault, or are you using like etcd on Kubernetes to store the secrets for the session keys?
We are using HashiCorp Vault. So what we actually, I mean, on the NodeMchart you have a very basic, you have some kind of example. So, for example, some things that we are able to do is like in GCP, use the authenticate with a service account, GCP service account, map it on the pod. So basically the node is running in a pod. It has this identity from GCP, and then we are using that to authenticate to Vault and get the secrets, without any credentials, deployed manually.
Yeah. So what, workload identity?
Yeah, workload identity. Yes, that is. But you could use different ways. But I mean, if you go this route, you will see it's more complicated than it first seemed. But it's interesting.
Okay. And just last one around monitoring and observability, because that's a big one. On Substrate, it exposes telemetry. I noticed you guys are using like Prometheus and Loki for observability. Like, what are you advanced in that, or are you still like in the initial stages of setting that up?
No, it's definitely working well. So each Substrate node has a /metrics endpoint, and those metrics are actually very, very useful for many things. I think we also have some sample dashboards, but basically you have metrics for like a lot for like basic things like block production, finalization, but also for like what's going on inside some of the subsystems of the node. But it's definitely possible to monitor it very precisely, and if you work like on a Parachain team, it's also possible to expose the stuff that you actually do as like a custom metric.
Yeah. Okay. And in terms of like so you have metrics you're monitoring. How are you sending out alerts for those? Are you just like doing it on Prometheus?
You have to use an alert like Alert Manager, Grafana.
Okay. Yeah. Cool.
Thank you.